Hi guys, and welcome back to my channel. In this video I will talk about this little setup right here. Um, this is a very simple but awesome sounding ZVS flyback driver. So first of all, let's talk about the components. So right here we have the standard Chinese ZVS drivers. So they are unmodified, they are normal drivers, and I have two of them. And well, normal DC flybacks. And well, then we move on to this thing right here. Let me remove the cables. This is the real driving circuit behind it. So it's just a MOSFET on the ground of the ZVS. And well, this is the supply and signal. So I will show it on the schematic so you guys can understand it a bit better. So basically, here we have our standard ZVS, and here we have a Midi source. In my case, I'm using an Arduino, but you can also use a standard Tesla coil interrupter or something. So anything that puts out a square wave, in Midi square wave. So basically then this gets fed into an optocoupler. So they're sitting right here on my setup. And then you have a 9-volt supply. So I'm using a bench supply, but I would recommend a 9-volt battery or something to you don't will have any problems with interference. So a 9-volt battery is definitely the best choice. Then if this LED switches on in the optocoupler because of a Midi signal, this photo transistor will switch the gate of the EFP on. And well, here's the normal pull down resistor, and the MOSFET sits on the ground. So basically here we have our PWM signal, and this signal then gets fed into the MOSFET, which then gets fed into the ZVS, and this signal will also be on the plasma. So then the output of the plasma will be like this, so also the sound. And now if we change the frequency and pulse width, we can create music. And well, that's basically how we can hear music, because we are changing the frequency and duty cycle of this PWM signal. So that's how we you can hear sound. So like I said, I'm doing it with an Arduino, but you can really use anything. And I think this is as good as you can get with a normal ZVS. So it sounds pretty awesome, to be honest, for its simplicity. So let me switch it on and demonstrate it for you guys. So then you can take a quick sound check. So enjoy. Well, it sounds awesome, doesn't it? By the way, this is my supply. I'm feeding the ZVS 32 volts. And just a quick tip, these MOSFETs aren't getting that hot, but if you run this setup more than 1 minute, I would recommend to put a heatsink on these MOSFETs. Also, it's definitely good if you put an ceramic cap on the LED of the optocoupler, because there will be a lot of RF noise going in your circuit otherwise, so this will filter out a bit of the RF, because, well, then your signal would look very trashy and it could cause problems. So definitely use this, and just a small tip, place it as close as possible to the LED. So yeah, that's basically it. And you can scale this up with as many ZVS as you can imagine. You can use 2 like I did, or you can use 3, you can use 8. I mean, yeah, you basically have a lot of options. And maybe if someone is interested, I'm using the Arduino code library, Midi library, the standard Midi library. So nothing special, but it works and it sounds awesome. So yeah, this was a quick video about it. I hope you guys liked it. Obviously there are a lot of better drivers out there, and I will link a very good one, but this is pretty much the best ZVS that you can make. I mean, all the other flyback drivers, MIDI flyback drivers, are based on a different complicated driver, and well, this is as simple as you can pretty much make it. I mean, everyone can make this, so yeah, it's definitely worth trying. I would really recommend this project, and yeah, if you guys have any questions or something, just leave a comment and I will try to answer it as good as possible. So yeah, see you guys in the next video.